Look at this question. If V1 is equal to 10 volts and Vt is equal to 5 volts, then the output voltage V0 of the circuit shown is a very simple circuit. This one. See, so far what we have observed is, suppose I have cathodes of two diodes are at the same potential, and if the anode of diode D1 is at 10 volts and anode of diode D2 is at 5 volts, then blindly we can say only D1 is on and D2 is off and output is equal to 10 volts. Ideal diodes I am taking, because nothing is mentioned about the diode forward voltage and all. A very, very simple thing, because when cathodes are at the same potential, then the diode with highest anode voltage only conducts. That's what we have seen. Okay, but the problem is not so. Here 1 ohm resistors are connected. Then definitely when a resistor is connected in a diode circuit, definitely that will change the things like anything. Okay, so here we do not know this voltage and this voltage. Okay, then how do we do this problem? See, if you observe this, V1 is equal to 10 volts and V2 is equal to 5 volts. Then anode of D1 is going towards 10 volts and the cathode is going to ground. It looks like D1 is on. Similarly, if you take D2, anode of D2 is going to 5 volts and the cathode is going to 1 volt. So it looks like both the diodes D1 and D2 are conducting. Okay, I can't take this way, right? This is what we have seen so far. Now the scenario is completely different. So it looks like both D1 and D2 are conducting. So assume D1 and D2 are on. Then how do we find the output voltage? Once both are conducting means assuming ideal diodes. Okay, let me write that statement as well. As nothing is mentioned about the diodes, assume ideal diodes. Then what is the equivalent circuit? Ten volts, 5 volts, 1 ohm, 1 ohm. We output 9 volts. Then let me take this voltage, this node as X. KCL at node X. Applying KCL at node X. Then what we can write? V output minus 10 by 1 ohm plus V output minus 5 volts by 1 ohm plus V output minus 0 by 9, or V output by 9 is equal to 0. Then V output plus V output, P out 2 V 2 times V output plus V output by 9. So 19 V output by 9 is equal to, here I can write 10 plus 5, it is equal to 15. So what is V output? 15 nines 135 by 19. It comes around 7.1. Okay, it is fine. And don't think like, okay, we have got the answer, because you can see that answer here. Always, whenever you have the diodes in a circuit, you just cross check. Means what we have to do next. Find the currents through each diode. This current I can say ID1 and this current ID2. What about ID1? No issues. ID1 is equal to 10 minus or V1 minus V output. I will write that also, not an issue. V1 minus V output by 1. That means 10 minus 7.1, it is equal to 2.9 amperes. It is positive, no issues. And what about ID2? It is V2 minus V output by 1. Here you can see it is 5 volts and V output is 7.1 volt. 5 minus 7.1, it is negative. I need not even calculate. Anyway, minus 1.9. Once the diode is in conduction, it is not possible to have a negative current from anode to cathode. So it is not possible. Implies D2 is off. Once D2 is off, what is the equivalent circuit? And output also cannot be 7.1. And ID1 also cannot be 2.1 amperes. Something else. We need to find that. So the equivalent circuit, what we can write? 5 volts, 10 volts, 1 ohm, 9 ohms the output. Entire current goes like this. This is nothing but ID1. Okay. So this is how we can find it. So V output is equal to 10 volts by voltage division rule, 1 plus 9 into 9. It is 9 volts. Okay. We can write it. Just what about ID1? ID1 is equal to 10 by 1 plus 9. It is 1 ampere. Even ID1 cannot be equal to 2.9 amperes, right? V output cannot be 7.1 volt and ID1 cannot be 2.9. It's all we have got due to the assumption of uh, uh, both the diodes are conducting, not ideal diodes. Anyway, it is mentioned ideal diodes. As we assumed that both D1 and D2 are on, we got this kind of results. But from this result, if you see ID2, definitely it is negative, which is not possible. Okay, only D1 conducts and D2 does not conduct. This is how we do the problem. So what is the answer? Option A is correct. Okay, this is the idea here. Then see this question. It was the question asked in previous gate papers. Find the value of I and V in the circuit shown in given figure. Okay. So here we can observe that all anodes are at the same potential, not the cathodes. Then which diode conducts? Okay, if you see here it is 5 volts, it is 3 volts. If I assume this as D1, it looks like D1 is conducting. And D2, right? It's a anode is going to 5, cathode is going to 2. It looks like D2 is also conducting. And if I assume this as a D3, anode is going to 5, cathode is going to 1, D3 is also conducting. But it looks like all the three diodes are conducting at the same time. We can't find the currents ID1, ID2 and ID3. Okay. Earlier problems, we could able to calculate the currents ID1, ID2, ID, etc. Based on that, we can able to conclude. But here, how do we do this problem? Okay. Again, we studied previously that once you know the cathodes are shorted and the diode with highest anode voltage only conducts. That's how we concluded without calculating the diode currents. Okay. In a similar fashion, here what is possible? Here the diode with, see, for the diode to conduct, anode voltage should be greater than cathode voltage, or cathode voltage should be less than anode voltage. Simple. So means the diode with lowest cathode voltage only conducts. Remaining diodes will be simply off. That's it. How is it so? See this. If I take this particular problem, as they have not mentioned anything about the diodes, assume ideal diodes. Then, if right, let us let me draw the circuit here itself. If D1 is on, the voltage here will be simply 3 volts. Similarly, if D2 is on, it is short circuit, so voltage here will be 2 volts. Again, if D3 is on, it is short circuit and 1 volt. Is it possible to see 3 volts, 1 volt, 2 volts simultaneously at the same node? Impossible, absolutely wrong. Right? My assumption is wrong then. I can't take all the 3 diodes are in conduction. Okay, which is absolutely wrong. It is not possible. Without calculation of the current through the diode, this is how we can conclude. Then what is true? Okay, you see here, if I take once D3, D1 is on, 3 volts will be coming here. The 3 volts makes the diodes D2 and D3 also to conduct, so that this is a circuit which is not possible. Then what is possible? Suppose D3 is on. Okay, if D3 is on, the voltage here will be 1 volt. Then the anode of D2 is at 1 volt and cathode is at 2. D2 will be off. And anode of D1 is at 1 volt and cathode is at 3 volts. So D1 is also off. This is the absolute answer. Okay, so my assumption itself is wrong. I assumed ideal. Okay, this is fine, ideal diodes. But if I assume the diodes are in conduction, this is what we can see. Okay, then what is the thing we can do? Only D3 is on, D1, D2 will be off here. Only D3 conducts and D1 and D2 are off, or they do not conduct. What is the equivalent circuit? I need not write all those things, it looks kiddish. 3 volts, 2 volts, 1 volt, 5 volt, 1 K. It is mentioned V is the voltage with respect to ground and this current I. So what is V? It is short circuit. The voltage here will be equal to 1 volt. And I is equal to, this voltage is 5 and here the voltage is 1. So 5 minus 1 by 1 kilo ohm, that is 4 milliampere. So V is 1 volt and current is 4 milliamperes. Option A is correct. This is how we can do this problem. Okay, so what is the conclusion? You may have a number of diodes, but the diode with right, when anodes are at the same potential, anodes of N diodes are at the same potential, then the diode with lowest cathode voltage should be low, and the diode with lowest cathode voltage only conducts and the remaining all diodes will be off. This is the statement we can write. Okay, here I am writing the statement: when anodes of N diodes are at same voltage, then diode with lowest cathode voltage only conducts. This is the important conclusion from this problem. Okay, that's it. And here also, this is also conditional, like what we have seen earlier, right? And previous problem, you see, I started with some confusion, like cathodes are at the same potential, then the diode with the highest anode voltage only conducts. But such thing is true if you know the anode voltages directly. Okay, cathodes are shorted. And the same similar scenario is possible even here also. Here, anodes are shorted, but the cathode voltages are known. Then I can comfortably decide which diode conducts and which diode doesn't conduct. If you have some resistors here also, something like this, then uh, we do not know. We have to take the nodal analysis and find the current through each of the diodes. Based on that only we can do. Okay, next. See this, it's a question asked in instrumentation paper. For the circuit shown in figure, assume ideal diodes with zero forward resistance and zero forward voltage drop. The current through diode D2 is, yes. See here also anodes are shorted. Okay, and the cathode of D1 is going to 10 volts and the cathode of D2 is going to 8 volts. So which diode conducts? The diode with lowest cathode voltage only conducts. Even we can draw the same circuit like this. Of course, not required. This is a 10 volts, from 10 volts to 200 ohm resistor. After that, anodes of two diodes, we can write even like this also. One cathode is at 10 volts and another cathode is at 8 volts. Which diode conducts? The diode with lowest cathode voltage only conducts. That's it. Both are one and the same. Okay. Here it is a 10 volts means I can write positive and negative supply. This is what you can see. 8 volts means positive and negative supply. Of course, these two will join. Both circuits are one and the same. And here positive and negative, that negative comes here. It's the ground. Anyway, so only D2 conducts and D1 does not conduct. What is the equivalent circuit then? Ten volts, 200 ohms. It is short circuit and 8 volts. And one more thing, here it is 10 and it is 10. So definitely, right, the voltage here will be less than 10. So D1 will be off. In that way also we can say. But anyway, we know the general procedure. When anodes are, two diodes are at the same potential, then the diode with lowest cathode voltage only conducts. That's the statement I gave. This current is ID2. Okay, they are asking current through the D2. So ID2 is equal to 10 minus 8 by 200 or zero point 0.2, 200 ohms or zero point 0.2 kilo. So how much do we get? 20 milliampere. That's it. Okay. This is how we can calculate the current through the diode. It's also a very, very simple question they asked. Sorry, 10 minus 8 2 means it's a 10 milliampere. Okay, that's it. Next question. See this. The circuit shown in the figure is a model for battery charger. Here V1 is a 10 volts sine wave. D1 and D2 are ideal diodes. I is a 10 milliampere current source and B is a 4.45 volts battery. The average value of IB in milliamperes is, means what is the average value of current through the diode D2? They are asking. How do we do this? I is equal to 100 milliampere or zero point 0.1 amperes current source. V input or V1 is a 10 volts peak sine wave, means V1 it is 10 sine omega t. battery B is a battery of value 4.5 volt. This is the meaning of it. See, so far what we have seen is anodes are at the same potential, and cathodes, one cathode is at some 3 volts, another cathode is at 4 volts, like the two different voltages we observed. DC only. First time we can see cathode of D2 is going to 4.5 volts DC supply, but cathode of D1 is going to a sine wave of peak amplitude 10 volts. Then how do we do this problem? So concept is same. Anodes are at the same potential. Then the diode with the lowest cathode voltage only conducts. So let us draw V1. Let us draw V1 based on that we can write. Or what we can say is, as V1 is like a sine wave, IB I am writing, it is just nothing but the current through the diode, how it will be. So as long as input is less than 4.5 volt, or V1 is less than 4.5, then what happens? Cathode of D1 will be at lesser voltage compared to cathode of D2. So D1 will be on. I can write. Okay. So if V1 is less than 4.5 volt, then D1 is on and D2 is off. Then what about the current ID1, and what about the currents ID1 and ID2? Definitely ID1, so it acts as open circuit, D2 acts as open circuit, D1 acts as short circuit. ID1 is equal to 100 milliampere and ID2 is equal to 0. Okay. Similarly, if V1 is greater than 4.5 volts, cathode of D1 is at higher voltage compared to cathode of D2. So definitely D1 will be off and D2 is on. If D2 is on, entire current goes like this only. D1 is off means it acts as open circuit. So ID1, so we can take ID1 is equal to 0 and ID2 is equal to 100 milliampere. Very simple point. Once you understand this one, right? You see, I'm not doing any wonder. We know the point, like when anodes of two diodes are at the same potential, then the diode with lowest cathode voltage only conducts. Instead of giving two constant voltages, one diode, cathode of one diode is at 4.5 volts DC power supply, and cathode of another diode is at a sine wave of peak amplitude of 10 volts. That's it. So as sine wave varies depending upon the voltage at the cathode of D1, D1 will be on or off. Obviously, once D1 is off, D2 will be on, and vice versa. That's how the circuit is. So let us draw ID2, how it is. So when input is, or V1 is greater than 4.5 volts, means this point to this point, D1 off, D2 on, and ID2 is equal to, or IB is equal to I. That's it. It is just nothing but IB. I can say so. And this is of course IB. Right? We can take that. Again, as long as V1 is less than 4.5, means this point to this point, D1 is on and ID1 is equal to 100 milliampere. When V input V1 is greater than 4.5 volt, then D1 off, D2 on, and the same story follows, continues. That's it. Like this we can take. Once you get the waveform this way, then we need to find the average value of IB or ID. Okay. How do we find it? So for finding average value, and what about IB? It is, of course, we have seen that. Let me do one thing. Average value of ID2. Average value of any signal, maybe current or voltage, whatever it is nothing but 1 by t integral 0 to t IB dt. Okay, we know that. Then what about the time period? And how do we define IB? We have seen the waveform, but remaining things, how to take the time period and all. As it is mentioned as sine wave, what I am doing is taking some instance. Okay, it is 0, this interval t1, it is t2, this is t by 2, and this is t. Okay, so what might be the time period here? Time period, one full cycle of a sine wave means time period I can write 2 pi. And what about t by 2? It is equal to pi. Okay, next, what about the period of IB? See, from here to here it is 2 pi. Same thing, 4.5 to 4.5, that is also again equal to 2 pi. Okay, means I can take this interval, its period as 2 pi. Okay, period of IB is known. Okay, T is known. Then how do we define IB further? Let me take this into two parts. This is capital T1. Capital T1 is completely different from small t1. This is T1 and this is T2. If I consider IB from this point to this point over an interval of time capital T1, IB is equal to 100 milliampere. And T1 to capital T, that is a duration, T minus T1, that is T2, or a duration of T2, it is, or from T1 to capital T, IB is equal to 0. We know that. Okay, so let me write that. IB, IB is equal to 100 milliampere over the interval T1. Okay, for T1 duration. T1. I can write 0 to T1, but already here this is mentioned as 0. That's why I don't want to confuse you guys. Okay, so we can write here or T1 to small t2. I can write. So the duration or a duration of T1 means that is T1, small t1 less than t less than t2. Similarly, IB is equal to 0 for a duration of t2. That is, see this, from t2 to, okay, t2 to, I can write T1 plus 2 pi. Okay, that is capital T2. Okay, T2 less than T less than 2 pi plus T1. Just for our understanding purpose only I am writing. Okay, even I need not mention all those things. Right. Right. What about the average value? Average value means as it has a proper shape, I can write area under the curve divided by its period. Okay, so what is the meaning of it? This portion gives us the area by time period, that gives us the average value. Okay, instead of that, or we can use the definition as well. Okay, so average value of IB, it is equal to area by period. What is the area here? Area means I can write 100 milliampere is the height and the width is T1 by period is 2 pi. This is also fine. Next, how to find T1, capital T1. That is our next point of interest. 100 milliampere into T1 is the area. Or we can even substitute in this. Formula is known, right? Not required. Okay. Then how to find capital T1? Yes. For that we have a clue. What is that? V1 is equal to 10 sine omega t. Then at t is equal to small t1, V1 value is sine omega t1, whose value is 4.5 volt. That's it. That point is enough. So my concern is how to find T1. Okay. For that, what I am writing is at T is equal to small t1, V1 is equal to 4.5 volt. Means implies 10 sine omega t1, it is equal to 4.5. Implies omega t1 is equal to sine inverse 4.5 by 10. If you see it, you will get it around 0.46. Omega t1. Omega t means it is in radians. Okay, not radians per second, it is in radians. Omega is radian per second multiplied with time. That gives it is in radians. Omega t1. Why I mentioned so? See this. If I take this angle as theta, theta is equal to omega t. Then what about this angle? This is also theta, because sine theta is equal to, or a sine theta is equal to a sine 180 minus theta, right? It is 180. Next, this should be, right? It is also 4.5 volt, means this duration, right? This interval is also theta. I can take it. Sine theta is equal to sine 180 minus theta. Simple mathematics. I am not doing any wonder. It's all about how good you are executing your mathematics. So let me call this as theta. Okay. Then what about T1? Here, T2 minus T1. Small t2 minus t1 is equal to capital T1. So how do we write it? T2 is equal to pi minus theta and T1 is equal to theta. So here capital T1 is equal to small t2 minus t1. T2 is pi minus theta, and t1 it is theta. So pi minus 2 theta, where theta is equal to 46 radians. So pi minus 2 into 0.46, it is equal to 2.2. We can write it. Okay, we can write this way. T1. Okay, of course it is taken in terms of the angles. Okay, then T1 we have got. Then what about the implies the average value of IB? It is equal to 100 into 10 power minus 3, that is 0.1 into 2.2 by 25. If you calculate it, you will get it around 35.35 milliamperes. 35 milliamperes you can write it. Of course, write it. You can take it, not an issue. This is how we can calculate the average value of the current through the diode D2. Now, the students can try this. Find the average value of the current through D1. Okay. So what might be the answer? Straight away we can take it. It's nothing but, okay, total is 100 milliampere. 100 minus 35.35. Okay, easiest way to write so. Or you have any confusion, you can write, now I can write ID1. ID1 is equal to 100 milliampere over the interval 0 to T1. And it is equal to, because if you take ID1, see 0 to small t1, ID1 is 100 milliampere. Again, from T1 to T2, ID2 is 0. So T2 to capital T, or I can write here this point, capital T plus T1, ID1 is equal to 100 milliampere. Okay, exactly opposite things we can see. It's just I'm writing it for the understanding of students, or I write the waveforms, right? Better. When ID2 is existing, that time ID1 does not exist, and vice versa. From ID2 I'm writing. ID2 we have got something like this. Small t1, t2, it is 2 pi plus t1. So it is t1 and 2 pi plus t1. The difference is 2 pi, which is the period. So what about ID1? When ID2 is existing, ID1 does not exist, and vice versa. Here ID1 is 0 and here it is existing like this. We can write, and even here also ID1 is present. Okay, like this we can see it is 100 milliampere. Okay, so average value of ID1 and ID2 should be equal to 100 milliampere. So average value of ID1, you can calculate it, and straight away I am writing average value of ID1, it is equal to 100 milliampere minus 35.35 milliampere. It is 5 6 65.65 milliampere, 64. That's it. Straight away I'm writing. The students can try this and check the answer. Okay. This is how we can do this.